Okay, for today's lesson we're going to work on finding area and perimeter on a coordinate plane. So now that we've reviewed the formulas for area, and we worked on rectangles, triangles, parallelograms, and squares, we can practice solving using those formulas on a coordinate plane. Let's first start with triangles. Remember, for triangles, the area for triangles is 1/2 times the base times the height. So we're going to apply this formula now onto a coordinate plane. The first step is going to be to graph the points, and then we can work on finding the area. We can also do perimeter, and I'll show you how we do that as we work. So the first coordinate is 1, 6. Second coordinate is 1, 1. Third coordinate is 5, 1. So here's my triangle. When we're looking for the area, we want to know the base of the triangle and the height of the triangle. So in this triangle, it's nice because these two sides are perpendicular to each other. So here's a little right angle. And I can tell that because these are on the same y value and these are on the same x value. So all I have to do is count the side lengths to figure out the length. So on the bottom here, this one is 4 units. And on the side, 1, 2, 3, 4, this is 5 units. So the area of that triangle would just be area equals 1/2 times base times height. So in this question it's half of 4 times 5. 4 times 5 is 20. And half of 20 equals 10. So the area of this shape is 10 units. To find the perimeter means you add all the sides together. But in this triangle, I don't know what the hypotenuse is. So we first have to find the hypotenuse, and then we could add all 3 sides together. So remember, to find the hypotenuse, we use the Pythagorean theorem, which is a squared plus b squared equals c squared. A and b are just your side lengths. So I've got 4 squared plus 5 squared equals c squared. 4 squared is 4 times 4, which is 16. 5 squared is 5 times 5, which is 25. Adding 16 plus 25, you should get 41. And then to find the square root of 41, you have to type that into your calculator. And for this one, we can use the decimal, because we're actually looking for the length. So clear out whatever's on your screen. Second square root 41. So 6.4 is what c is equal to. So on my triangle, I figured out the hypotenuse. And now that I have all 3 sides, I can add them together. 5 plus 4 plus 6.4 equals my perimeter. Adding 5 plus 4 plus 6.4 gives me 15.4 for the perimeter. So really it's similar steps, we're just applying it now on a coordinate plane. Okay, so let's look at the next set of problems. This time we're going to graph a different shape, and now we can find the area and the perimeter of this different shape. So the first coordinate is at 6, 1. So I'm going to go over to 6, and then up 1. That's point D. Point E is at 1, 5. So 1, 5. F is at 6, 5. And G is at 1, 1. Alright, so again, since the sides are completely vertical or completely horizontal, these are right angles, they're perpendicular. So we've created a rectangle. And since we've done that, we're able to just count the side lengths to figure out how long these sides are. So on the bottom, looks like it's going to be 5 spaces. Which also means on the top it has to be the same because on the rectangle the opposite sides are the same. On the sides it looks like it's about 4 spaces. So for area, remember area of a rectangle is just base times height. So in this case, it's just 5 units times 4 units. So the area is 20. Remember, if we counted on the inside how many little boxes there should be 20 of them. The perimeter is just when you add up all the side lengths around. So perimeter is your height and your base added together all the way around. So that's 5 plus 5 for the top and the bottom, plus 4 plus 4. So the perimeter in this case would be 18 units. And that's how easy it is to find perimeter and area of a rectangle on a coordinate plane. So now we know triangles, and we've done rectangles. Let's try one more with parallelograms. Okay, so for a parallelogram, it's the same idea. You're going to plot your points. So Q is at -2, 3. R is at 6, 3. S is at 3, -1. And T is at -5, -1. This one, we're just going to find the area, since the area is a little bit easier than doing the perimeter. Remember, for area of a parallelogram, it's base times height. So for our parallelogram, the base is easy to count because that makes a nice straight line on the -1 value for the y values. So I can just count how many units this is long. This looks like it's 1, 2, 3, 4, 5, 6, 7, 8 units long. So the base is just 8. For the height's a little bit trickier. Remember, for the height, we do not use the slanted sides for height. We always use heights that are up and down. So when you have a parallelogram, the best strategy is to draw in a height between the two sides that are nice and flat, that aren't slanted. Because now I can figure out the height between these two sides. And you can see that it makes a little right angle there if you look at the way they're intersecting. So now, how high is this number? This number also is 4. Base was 8. So the area is just 32. And that's all it is to find the area of a parallelogram. To find the perimeter, you would have to figure out the length of your diagonals here on the sides. And you could do that by making a right triangle and doing Pythagorean theorem. So if you want to challenge yourself, try to figure out the perimeter of the parallelogram as well as the area. Your practice problems just involve these, where you're finding area of triangles, rectangles, and parallelograms on a coordinate plane. Good luck.